Hello all. In this session, we're going to understand how we'll be able to implement a logistic regression using scikit-learn module. Okay, so initially we'll start with importing the necessary files. Initially, we will start with the NumPy. I don't need to explain what is NumPy. We're going to also import pandas. This imports the pandas libraries for the data manipulation and analysis. And here the next thing is scikit-learn model for selection import train test split. Why do we require to have a train test split? By this, we'll be able to import the function to split the dataset into training dataset and a testing dataset. And we also are going to import a linear model from the logistic regression. This is imports a logistic regression model, which is a actual model that supports logistic regression in the sklearn scikit-learn. Okay, we also will import several metrics which will be by using which will be able to predict accuracy score, confusion matrix, and the classification report, and etc. Now, let us initially will create and load a data set. Here, we're not directly taking a data set. We just are going to create a synthetic data set. Okay, customized synthetic data set. Okay, to create generate synthetic data, what we do is we'll take x comma y is equal to make classification. We're going to use some function which is called make classification, in which the first parameter is the number of samples, which is equal to here we are initializing it to 1,000. That's 1,000 data points. Features, the total features on which we're going to classify is equal to 4, and the number of classes will be equal to 2, maybe 0 or 1. And random state, here we are seeding with the 42. It's a generalized random state, which is going to give us the same random number all the time. Okay, which is around it to 42. Now, train test split will be exit train, comma, exit test, y test is equal to, we're going to use the function train test split, in which x and y will be split into 20%, and test size will be 20%. The training size will be equal to 80%. Now, let us understand what is xy. Xy is equal to make classification. This generates a data set with 1,000 samples, as with 1,000 data points, with the 4 features and 2 classes. What is x here? The features. 1,000 into 4 array. Okay, what will get created? 1,000 into 4 array will get created. Each row represents a sample and each column represents a feature. There are 1,000 points. There are data points. Each row is a record where each column is going to represent a feature. Y is the target variable where it is getting classified into maybe a dog or a cat, or rather it's a 0 or 1. It will be target variable, the output layers. A 1D array of length 1,000 with the binary values 0 and 1. Here, as we discussed, we're going to have a binary classification that is in between 0 and 1, representing the class labels. 0 and 1 are the class labels. Okay. There are several classes. The first class will be 0 or 1, or whatever the label that you want to create, you can create. But here we are taking 0 and 1. Here we train test split. The train test split function, as discussed, is going to divide it into 20%, comma 80%, where 20% goes for the testing and 80% goes for the training. And our model is getting initialized. How to initialize the model? The class logistic regression is being instantiated, okay, and being passed to an object called model. Our model will be the logistic regression class, the instantiated class that we are using from the scikit-learn, because you know that the logistic regression has already been imported, and we are going to, there is a function called fit in the model. We are in a logistic regression model. There is a fit function which takes 2 parameters, x train and y train. Okay, so this is, we're going to pass our x train, y train we created earlier will be passed as a parameters. Right, then the model is equal to logistic, as I already told you, model is equal to logistic. This initialize the logistic regression model. Model fit x train, y train. This fits the model into the training data. Okay, now let us make the prediction. What is the y prediction? Y prediction is the output class that we are determining. Here, what we need to do is model.predict. In model.predict, predict is a function. We are going to pass the parameter exit test. The each variable will be passed, in which that will be passed to this model and will be classified into y prediction. Y prediction is equal to model.predict exit. This makes the prediction using the trained model on the test data set we discussed. Okay, let's evaluate the model by using various techniques. First one is accuracy is equal to accuracy score. We're going to take an accuracy score which is also another function to which we're going to pass this y test and y prediction. We're going to, what is the y test and y prediction? Prediction means, see, there is an output. There is already a class. For an example, the prediction is 82, and the actual output is 100. 100 minus 82 will be your accuracy, right? Okay, so the accuracy score is equal to y test and y prediction. It will be passed here. Confusion matrix with their confusion matrix produced, to which we need to pass y test and y prediction. The report, there is a report function by using which classification underscore report y test and y prediction, by using which a report will get produced. What we're going to print here, we're going to print accuracy, confusion max, and the report. Okay, here what is accuracy? Accuracy score is calculator model's accuracy. Model's model's accuracy. They generate the confusion matrix. This is accuracy, y test and y prediction. How accurate your model is performing. Report is classification report. This generates the detailed classification report. The print statement, as you know, it's going to print it. Okay, this is an optional y probability. Here, y probability is this generates the probabilities for each class. But since this is optional, you don't need. But anyhow, if you do want to implement this, let me explain this. There is one object called yproba is being initialized here, where I'm going to use predict underscore proba function, to which the parameter will be x underscore test. Okay, so here yproba is the predicted probabilities. It is going to print the predicted probabilities. Okay, so what exactly is the probability is being transferred to the yproba, that is being extracted by some function called predict proba, to which the parameter will be x underscore test. Thank you so much.